Today what we're going to do is we're going to continue on with chapter 10. We're going to be looking at graphs and equations in circles and angles and arc measures in circles. Primarily today what we're going to do is we're going to look at section 10.1a. So I'm going to split this section into two pieces. The first part is A, where we're using properties of tangents. And the first part of it, what we're going to do is we're just going to look at some vocabulary. Now we're going to start with just some general vocabulary. You're going to notice that I will be opening up soon a quiz where you will be taking a quiz on the different vocabulary in the chapter. I want to make sure that you get 100% between now and the time we take the test. And then that will be used toward your responsibility grade. But first, let's take a look at some definitions. First, circle. It's a set of all points in a plane that is the same distance from the center of a circle. And so if we think about a circle, here's my circle. The center of it is in the middle. And if I go from the middle out, they're all the same distance going all the way out. Kind of like a wagon wheel. The radius is the distance from the center of the circle to any point on the circle. And if you take a look down at this picture, you're going to notice that the radius is outlined here. It's from the center to the outside. And you're going to notice that there's several radii going all the way around the circle. The one that's highlighted here in this picture, you're going to notice is just one, and it's in the light blue. Then let's take a look at the next definition. The next definition is a chord. A chord is a segment whose endpoints are on the circle. And so if I go down to my picture, you're going to notice the chord. It's in purple. A chord just has the starting point on the circle and the ending point on the circle. And they can happen anywhere on the circle just as long as the two endpoints are on the circle. Now let's take a look at the next definition. It's the diameter. A diameter is just a fancy type of chord. So the beginning point and the ending point of the line segment are on the circle, but it goes through the center of the circle. And so you're going to notice down here in the pink, you have the diameter. You've got the start on the circle, the stop on the circle, and it goes through the center of the circle. We're going to keep going, talking about a secant. A secant is a line, and that's key here. It's a line that intersects the circle in 2 points. And so if I take a look at this, you're going to notice that green line. It's got arrows on it. It does have to have arrows on it because it's a line. And you're going to notice that it intersects the circle in 2 spots. Here's 1 point, and there's 1 point. But you're going to notice that this has 2 arrows because it's a line. That's what makes it a secant. And then finally, tangent, a line that intersects the circle in only 1 point. So you're going to notice that it's the red line down here. It's a line that wants to shoot across the circle, but it misses, and it only touches the circle or kisses it in 1 point. And that is called a tangent line. And then point of tangency. It's the point where the tangent line intersects the circle. And you're going to notice that I took this black arrow and I brought it down here and I pointed at it. This point right here where the radius or the diameter touches the tangent line, that's the point of tangency. So these are all words you're going to really need to know. Some will be matching on a test, but it could also be just describe them or draw them for me. So make sure that you really understand what those words are. All right, now that we know what those terminology words are, we're going to go a little bit further and we're going to talk about coplanar circles. What that means is I have 2 circles and they either intersect each other or they just touch each other or one's inside of the other. The main thing that we're going to look at is the points of intersection. So if I look at the first grouping, it's 2 points of intersection. And when that occurs, you've got 2 circles that they're kind of one goes in the other, kind of. And the 2 points of intersection are here and there. And then if we look a little bit closer, if we wanted to talk about lines that are tangent. So you're going to find out in the assignment today that you're going to have to draw tangent lines. And what that looks like is how many common tangent lines can be drawn on these. And so what that looks like is I can draw a line that goes from here and here. Okay, and I want to move this a little bit. I want to bring this up, this line up. Oh, it's not doing it for me. You want to draw it so that it just touches both of the circles like this. So it touches it here and it touches it there. That's one tangent line. And then another one that can be drawn is here and here. So there are two tangent lines that can be drawn when the two circles look like this. So there are two tangent lines, two common tangents. Okay, now let's take a look at another way that circles can be intersect each other. One point of intersection. So you're going to notice that on these two circles, I've got one point of intersection. It's like they're little kissing circles. And if I was going to draw the common tangents of this, one is like this, like we did before. They intersect the circles here. And like this. And I can also draw a tangent line that goes between the two like this. So in this example, there are three common tangent lines. If I look at this example, okay, this looks a little bit different because they touch a little bit different. So on this example, there is only one common tangent. Go a little bit further. Well, what happens if there's no points of intersection? Well, with the first one, there's really no way that I can do a tangent point that touches both of them. So there would be zero common tangents on these two. But if I take a look at this one, there's quite a few of them actually. So I've got one that will come like this, like before. I've got one that goes like this. And then there's ones that can go kind of crisscross. So they touch here and touch there. And another one that comes from here and goes there. So on this example, there's four common tangents. So again, the tangent lines, what they do is they go so that they touch the circle in only one spot. And so if I got two circles and I need a line to touch both of them without going through them, that's a common tangent. So these are some things that you're going to want to take a look at. If you have questions, let me know. It will be on quizzes. It will be on tests. So just kind of a heads up on that. Finally, we're going to look at a theorem. The first theorem says that if a line is tangent to a circle, so you're going to notice this black line is tangent to the circle, then it's perpendicular to the radius drawn to the point of tangency. So what it's saying is if it is a tangent line, then it's perpendicular to the radius. Okay, and the converse is also true. So just kind of a heads up, talking about the radii and the tangent line, that they're perpendicular, and that will be important as we solve problems. So let's go down now and let's solve this problem. It says the line segment RT is tangent to the circle at R. Find the length of the radius. And so what I'm trying to find in this is, remember, the radius is from the center out. This is the radius, and from here to here is the radius. And what we're going to use is, we're going to be using the Pythagorean theorem because RT is tangent to the radius, so I know that's a right angle. So to do this, what we're going to do is we're going to set up our R squared plus 12 squared equals R plus 7 parentheses squared. Okay, and how I know that is, again, this is my hypotenuse of my triangle, so that has to be the R plus 7, and it does need to be in parentheses squared. Okay, now what we're going to do is we're going to come down here and we're going to try to solve for this. So I'm going to go R squared plus 144, because 12 squared is 144, equals, and this is R plus 7 times R plus 7. We're going to keep going. We're going to go R squared plus 144 equals. We've got a little bit of a problem here. This is something that you learned in algebra. And so I'm going to kind of go through it with you quickly here. If you need more review, let me know. But it is something that you handled in algebra. What we're going to do is we're going to form some squares. So we're going to multiply. It's a 2 by 2. So I'm going to go R and a 7 here. That's the first one. And an R plus 7 here. That's the second one. And if I go R times R, I get R squared. And R times 7 is 7R. And 7 times R is 7R. And 7 times 7 is 49. And then you're going to notice that these two terms, this one here and this one here, they're like terms. And so we're going to add those together, and I end up with 14R. So my answer, when I multiply it together, is R squared plus 14R plus 49. Okay, what a lot of students want to do is they want to just go, they want to say, well, it's just R squared plus 49, and that's not true. There's a hidden term in there. So when you do those, just make sure you go off to the side and multiply with your boxes. Okay, so we're going to come back here. I'm going to subtract R squared from each side. So if I do that, I end up with 144 equals 14R plus 49. I'm going to subtract 49 from each side. So 144 minus 14 gives me 95. I'm going to divide by 14, and I end up with 6.79 units. And I'm just going to round to the nearest hundredth on that. Again, I think the hardest part that you're going to have on this is this part right here. Do the best you can. When we talk again, if you have questions, I'll be happy to answer some of those questions for you. All right, and finally, we're going to go to the last one. Given the following, is line segment AB tangent to the circle? So it's asking you, is this line tangent to the circle? And again, I'm going to use the Pythagorean theorem. So I'm going to grab my 7 squared plus 24 squared, and I'm not sure what's going to happen here, and I'm going to go 25 squared. And for it to be tangent, it needs to be a right triangle, which means I should have an equal sign between. So I'm going to go 49 plus 24 squared is 576. This is 625. So I add 576 plus 49. I get 625 and 625. Which means that it's equal. And because it's equal, it's a right triangle. So because they are equal, the radius is tangent to the line segment AB. Okay, so it is tangent to line segment AB, which means that AB is perpendicular to AC, which makes it tangent. So it's yes. If it's not equal to, then they're not tangent. So the whole idea is right triangles, and we have worked on that before. Again, if you have any questions, please don't hesitate to ask, and I'll see you next time.